In this video, I'd like to talk about the formula for an infinite geometric series. And I've written out a very general geometric series here that is in fact infinite, where A is just the first term in this geometric series, and R is the common ratio. And in this case, we don't have an n value like we did for the finite geometric series formula, since this is going to go on forever. There are an infinite amount of terms that we're going to be adding up. And the way to find the formula for this is going to be very similar to how you would solve any specific example problem that we've looked at in previous videos, where we're essentially going to set our series here, this sum, equal to s, and then multiply the entire sum by the common ratio, and then subtract one series from the other. So that's the approach. And just so that you feel familiar with this geometric general series we have, let's just actually plug in some specific numbers. So let's say, for example, that A is 6 and our common ratio is 1/2. And at the end, we can test to make sure our formula works with these specific numbers. So this series would actually look like 6, since that's our starting term, plus our starting term multiplied by our common ratio, so 6 times 1/2, which is 3, and then we have 3 times 1/2, which is 3/2. 3/2 multiplied by 1/2 would be 3/4, and of course this is going to go on forever. And for these, since they are infinite, our common ratio needs to be a fraction for this to actually converge, or for this to actually approach some value. Since if this is not a fraction, the terms will get bigger and bigger. For instance, if we just chose r equal to 2, and we'll keep that same starting value, this would be 6 plus 12 plus 24, where now all the terms are getting bigger and bigger as they go on. And basically, to use the correct language here, this sum, where the common ratio is a fraction, this will converge. But when the common ratio is not a fraction, when it's bigger than 1 or equal to 1, since the terms get bigger and bigger as the term number approaches infinity, this sum will get bigger and bigger. It will approach infinity, and we'd say that it diverges. So if the common ratio is a fraction, it converges. If it's not a fraction, if it's bigger than or equal to 1, or it could be negative and bigger than or equal to -1, then it will diverge. It will approach infinity as the term number gets bigger and bigger. So that's a key difference between the finite geometric series formula and the infinite one. So we have to be careful here with our common ratio and make sure that certain conditions are met. And we'll talk more about that at the end. But for now, let's try and find that formula. And so, like I mentioned, we're going to take our original series here and just multiply by the common ratio. So we'll look at r times s. And once we have this series, we'll take the one in blue and subtract the new one that we're creating, and we'll be able to come up with a formula. So we are multiplying a by r, since we're just distributing r to all of these. And so a multiplied by r is just ar. Then we have ar times r, so now there's two r's, or ar squared. Then we have ar to the third multiplied by r, ar to the second multiplied by r, which gives us ar to the third, and ar cubed multiplied by r gives us ar to the fourth, and so on. This will go on forever. Now, to find the formula, we're just going to take our original sum, which we called s, and subtract this new series that we created. So we're subtracting r times s, and we'll be able to notice a pattern. So notice in our original sum, we have this term a, and there is no like term in this new series that we can subtract away. So a is going to remain. But then we have ar minus ar. So those will cancel. We have ar squared minus ar squared. Those cancel. Ar cubed minus ar cubed. Those cancel. They all just equal 0. And of course, you'd have AR to the fourth here, which will cancel out with this one here. And essentially, every single term from the blue geometric series will cancel out with every single term from the yellow one, except for this term that we started with, A. And so when we subtract one from the other, it's just equal to A. And from here, we can solve. So we can solve for S. We could factor S out from each of these two terms. Here we're left with a 1. Here we're left with minus R. And just to finish the formula, we divide each side by 1 minus R, so that S, our sum, would be equal to A divided by 1 minus R. So this is our formula. And like I mentioned, we can now test it with this geometric series we created. So let me just make some room for that. And for our example, let me continue with that same color. Now we're going to plug it into the formula. A is 6, and we have 1 minus our common ratio, which is a half. 1 minus a half is a half, so we have 6 divided by a half, and 6 dividing by a fraction is the same as multiplying by that fraction flipped over, so 6 times 2 over 1, which is 12. So this infinite geometric sum we can very quickly do now, since we have a formula, and that will just be equal to 12. Now, I do want to show you, you can plug in A and R into this sum here, but you're going to see you get something that doesn't make sense. So if we try to add up this 6 plus 12 plus 24, we can know intuitively that this is just going to get bigger and bigger, so it's going to approach infinity. But if we want to plug it into the formula, we know A is 6, and we have 1 minus that common ratio, 1 minus 2. So you get 6 over minus 1, which is negative 6. And you can see that doesn't really make any sense. We're adding up a bunch of positive numbers. They're getting bigger and bigger, but somehow, based on the formula, we get negative 6 as our answer. So this is our formula, and our sum will converge, but our common ratio has to be a fraction. So let's write that out a little bit more formally, just so that we can be clear on it. So S is A over 1 minus R, and we can say S will converge. So actually approach a number, we can say when R is between 1 and minus 1. And it can't be equal to either of those endpoints. It needs to be a fraction, but it can be a negative or a positive fraction. And a lot of times you'll see this written as the absolute value of R needs to be less than 1, but these are equivalent to each other.